Hey y'all, we are going to review systems of equations. So if you go ahead and find in your packet, the packet that we've been working on for a long time, find this page. It's towards the end, before the word problems. And we're only going to do a certain one together. We're going to start on number 2. So we're going to practice the different methods. There's graphing method, substitution method, and then elimination. And within elimination, there is addition, subtraction, or multiplication. Okay, so we're going to practice all those different methods of solving systems of equations. Remember, there's always going to be 3 types of solutions. Remember, one of the solutions is you could get one solution, which you get means you get an x and a y. That's when you have lines that intersect. Another one is no solution. And that is when your lines are parallel. There's going to give you no solution. And the very last one is you could get infinite solutions, which means the lines are literally the same. You can either put the symbol or write infinite. So we're still getting those 3 types of solutions. It just depends on the way they want us to graph, or the way they want us to solve it. So we want to solve it the way they tell us to, okay? All right, so solve each system of equations by graphing. So this number 2 that we're doing, they want us to graph. Remember, in order to graph, my equations have to be in what form? Think about what form they need to be in for me to graph. And hopefully you answered they need to be in slope-intercept form, which is y equals mx plus b, because you need to know the m and you need to know the b in order to graph them. So if I look at this first equation, that's definitely not in slope-intercept form. So I'm going to take that down on the side here, and I'm going to get it in slope-intercept form. I'm trying to get y by itself, so I cannot touch that 2y until I get rid of that positive 1x. How do you get rid of positive 1x? Subtract 1x. So you're left with 2y equals, remember, these are not like terms, so you cannot subtract them. So put the x part first, and the constant number part next. And then if I divide everything by 2, I get y equals, reduce if I can, negative 1/2 x plus 3. So for this equation, I have it in slope-intercept form. Think about what's your m and what's your b. So my slope is negative 1/2, and my y-intercept, negative 1/2, and my y-intercept is 3. In order to put it on my graph, I start at the y-intercept. The y-intercept is positive 3, so on the y-axis, where is positive 3? Then I'll do my slope. The negative 1 in the rise tells me to go down 1. The positive 2 tells me to go right 2. So down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. And I'm off. Now go back to where I started. Up 1, left 2. Remember, you want to get as many points as possible. It makes it as accurate as possible. And try to make as straight of a line as you can. A little bit harder on here, but I did pretty good. Right, so we have one equation graphed. I remember, you should have a ton of dots. Sometimes you can only have 3 dots. Sometimes you can have a ton. It just depends. All right, now my equation x equals 4. Think about that. What type of line is that when you have x equals a number? I bet you some of you are probably saying undefined line. It's an undefined slope. But what type of line? An undefined line, think about that. It makes a vertical line. So go to your x-axis. Where is x4? 1, 2, 3, 4. Remember, it makes a vertical line because it's an, oops, that's not straight at all. Remember, it makes a vertical line because it has an undefined slope. So yes, if I put a dot here, x is still 4, y is different, but x is still 4. I go put a dot right here, x is still 4, y is different. So that is why it makes a vertical line, because anywhere along this line vertically, x equals 4. Now it looks to me like these lines intersect, so tell me your answer. Don't just stop here. Intersecting lines have one solution. So my answer is one solution, and tell me what that one solution is. So it looks to me like it is 4 positive 1. You can always check yourself on your graphing calculator, but if this work is not done, especially for that first one, you're not going to get credit for it. Okay, so the goal of using our graphing calculator so much is to help us and to check ourselves, but not to just use it to find your answer really quick because you don't want to do the work. Okay? All right, so that's one on a graphing. The next set of directions says solve each system of equations by substitution. So we're going to look at number 5 in this section. Now remember, for substitution, you have to have x or y by itself for one of your equations. And if I look at my equations, it doesn't look like I have x or y by itself in one of my equations. So I need to do some thinking. Think, what equation would you like to get x or y by itself? Do you want to use the top equation or the bottom equation? Hopefully you said the bottom equation. And hopefully you realize it's easiest to get that x by itself. So I need to get rid of negative 4y. So add 4y. So x equals, these are not like terms. Don't put them together. So put your 4y and then put your constant number plus 12. So now I'm changing this to x equals 4y plus 12. Now that you have one of your variables by itself, you have x equaling this. That means wherever you see x in the top, you're going to put in what x equals. So let's rewrite the top. 3 times x, which is now 4y plus 12, minus 5, I finished writing the top, minus 5y equals 15. So I substituted for my x. Now I can go ahead and solve. What do I need to do to solve first? Get rid of those parentheses, so distribute. 3 times 4y is 12y. 3 times 12 is 36, and then leave the rest. I'm left with a bunch of y's, so what do I need to do next? Looks to me like I got to combine like terms, so 12y minus 5y is 7y, and then that 36 has nothing to go with it. So now this should be easy. You're getting y by itself. You cannot touch 7 until you get rid of the plus 36, so minus 36. So 7y equals, what is that, 21, negative 21? Divide both sides by 7. Negative 21 divided by 7, y equals negative 3. Remember, if you get one of your variables to equal a number, you know it's got to be one solution. You showed your work to solve for y. Now you need to find x and you need to show your work, not just get the answer from the calculator. So I take my y and I plug it back into the equation that I used for substitution. So this one right here. So x equals 4 times y. Well, y is now negative 3 plus 12. And I'm going to solve for x. I got to multiply first. So that gives me negative 12 plus 12. And negative 12 plus 12 gives me 0. So these lines, if I were to check on my graphing calculator, they would intersect at this point. Remember, checking yourself on a graphing calculator is perfect, but if this work doesn't match it, you're not going to get credit. So that's a substitution one. Now let's look at some elimination. All right, elimination. Remember, we have elimination by addition, we have it by subtraction, or we have it by multiplication. So elimination by addition, I use that when my coefficients are opposite. Subtraction, I use it when my coefficients are the same. And I'm going off the paper here. And I use multiplication when no coefficients opposite or same. I'm going to multiply to get them the opposite or the same. And then once I multiply to get them the opposite or the same, then I can use my addition or subtraction. Do not forget, opposite means same number, different signs. Okay? So that's the biggest issue sometimes. Opposite means same number, different signs. All right, first and foremost, they have to be in standard form. X and Y have to be together on one side, and your X's and your Y's need to be lined up. It looks like I have that for both of these. X and Y on one side, X and Y on one side, X is lined up, Y is lined up. So you're good to start. Let's look at the coefficients on X. I got a +2 and a +8. They're the same sign, but not the same number, so I can't subtract. I have a +2 and a -2. Looks to me like those are opposite. And opposite tells me I need to add to eliminate what's opposite. The reason why they eliminate is because 2y plus -2y becomes 0. Now let's add everything else. 2x plus 8x gives me 10x. 28 plus 22, does that give me 50? If I finish solving for x, divide both sides by 10, x equals 5. Remember, you know if you get one of your variables to equal something, it's got to be one solution. Now I just need to find the other variable. How do I find the other variable? Hopefully you remember, take this x, plug it into one of these equations, either the top or the bottom. I always just use the top. So I'm going to take that top equation, and wherever I see x, I'm going to put a 5. So 2 times x plus 2y equals 28. My goal is to get y. So I got to do this multiplication. 2 times 5 is 10. So 10 plus 2y equals 28. I can't touch 2y till you get rid of +10. How do you bring the +10 to the other side? Subtract 10. So 2y equals 18. Finish getting y by itself by dividing by 2. So y equals 9. Remember, if you chose the bottom one to plug x back into, you would get the same exact answer as long as you did your work correctly. So these lines intersect at that one point. That's the only point that makes both of these equations true. All right, let's go ahead and see what problem we have next. All right, let's look at number 10. I believe number 10 falls under the same directions for elimination. Okay, so it wants me to solve this system by eliminating. Remember, in order to use elimination, standard form, x and y together on one side, which looks like I'm good for both of them. X is lined up, y is lined up. So it seems like I'm ready to begin. I gotta look at coefficients. Remember, I use addition if I see opposite coefficients. I use subtraction if I see the same coefficients. And I have to multiply if I don't see opposite or the same. So let's look at what I got going on here. I got a +4 there and a +7. They're the same sign, but not the same number, so I can't subtract them. Here I have a +5 and a -3. They're opposite signs, but they're not opposite numbers, so I can't add them. So I've got to multiply. And this is where you have to think to yourself, since my x's were the same sign, do I want them to get them to be the same number? Or, because then if they're the same number, then I can subtract. Or, Since my y's are opposite signs, do I want to get them to be opposite numbers? And then I could add. I'm going to do the first thing. I'm going to get my x's to be the same number. So let's think about the number 4 and the number 7. Think about their multiples. So then we can see what's the first number they have in common. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. Let's try a couple multiples for 7. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. Uh-oh. The first number they have in common is 28. So I'm going to get those to both be a 28. Basically, I'm multiplying the top by 7 and the bottom by 4. Multiply every single thing in the top by 7. Every single thing. So don't make a mistake on that. So 7 times 4x is 28x. 7 times 5y is 35y. And 7 times 22 is 154. Now everything in the bottom gets multiplied by 4. 4 times 7x is 28x. 4 times negative 3y is negative 12y. And 4 times negative 32 is negative 128. Now I notice I have my x's to be the same. Same tells me to subtract to cancel them because they subtract to 0. Now subtract everything else and show your work. 35y minus negative 12y. What would that give me? 47y? 154 minus negative 128. So really, isn't that just 154 plus 128? Because a double negative becomes a positive. So that gives me what, 282? If I divide both sides by 47 in order to get y by itself, oops. What would 282 divided by 47? I'm getting 6. So remember, if you get one of your variables to equal something, it's got to be one solution. Okay? So you have one of your solutions, you've got to find the other. Remember, in order to find the other, you either use the first equation, the second equation, or actually you have a new first equation and a new second equation. Your choice. I'm going to make some room for myself over here. I told you before, I always just use the first equation to make it easy. It really is your choice. So I'm going to take this equation. Wherever I see y, I'm going to plug in 6. So 4x plus 5 times y, which is 6, equals 22. Multiply first. So 4x plus 30 equals 22. You're trying to solve for x, so you can't touch 4x till you get rid of plus 30, so minus 30. So 4x equals, what's that, negative 8? Finish getting x by itself, so divide by 4, and negative 8 divided by 4 would be negative 2. Now, some of y'all may realize something different. Some of y'all, so I went ahead and I multiplied the top by 7 and the bottom by 8 to get my x's to be the same. That's not the only way you could do it. Remember, we talked about the y's. Look at the y's. We talked about them being a positive 5 and a negative 3. So they're opposite signs, but not opposite numbers. Well, what if you got those to be opposite? I'm going to show you another way. You probably don't have room for this, and that's fine, but I just want to show you another way. So if I wanted to get those to be opposite, well, 5 times 3 is 15. That's the first number they have in common. So what do I have to multiply this 5 by to get a 15? I have to multiply it by 3. Everything gets multiplied by 3. So that would be 12x plus 15y equals 66. In the bottom, if I want to get this to be a negative 15, I have to multiply the negative 3 by a 5. So what does that give me? 35x minus 15y equals 32 times 5, or negative 32 times 5 is negative 160. And then this scenario that I made, these are opposite, and opposite tells me to add to eliminate. So 12x, add everything else, plus 35x equals 47x. And 66 plus negative 160 equals negative 94. If I want to get x by itself, if I divide both sides by 47, negative 94 divided by 47, x is negative 2. So in this situation, I got my x first, which is the same x I had before. Then I would just have to go back and solve for y. So there's more than one way at times for you to do it. All right, I believe I've tried a few with you. I think now, yeah, there's going to be some that you try on your own. I believe you're going to try on your own, and they're just like the 4 I did with you. I think you're going to try 1, 4, 7, and 9. Let me just refresh you really quick. Remember, if your variables disappear, because that may happen in some, if your variables disappear, and say you're left with 0 equals 0, it's true. So your answer would be infinite solutions. That would be if you had the same line. If your variables disappeared and you're left with 0 equals 12, well, no, that's not true. So that would be a no solution. So just a little refresher there. Okay? Email me and let me know if you have any issues.